Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
Question number 67 is very similar to question number 65. It is an Arrhenius plot calculation. Before you could carry out the calculation using the Arrhenius plot in order to determine the frequency factor and the activation barrier, you need to first prepare your Arrhenius plot. To prepare an Arrhenius plot, you'll take the data that is provided, the Kelvin temperature, and the rate constant values, and you will calculate the natural log of the rate constant and 1 over the Kelvin temperature. To do this in Excel, you simply put in equals natural log and then reference the cell that you want it to calculate the natural log value, and then hit enter, and this value is the natural log of this value. You can then grab the corner and pull it down, and then it'll finish calculate all of the appropriate natural log of the rate constant values according to their position in the columns. To calculate 1 over the Kelvin temperature, you'll type in equals 1 over and then reference the cell containing the Kelvin temperature, hit enter, same thing, grab the corner, pull it down, and it'll fill in all the appropriate 1 over Kelvin temperature values, A3, A4, and A5. Then to prepare your plot, you'll highlight the data, go to Insert, Chart, XY Scatter, and you'll get something that looks like this. You need to make sure that you have down here 1 over the Kelvin temperature, and on the y-axis the natural log of the rate constant. If you don't, then you need to select your data and switch your x and y values. When you do that, you should get a graph that looks something like this, where we have natural log of Kelvin, or natural log of the rate constant as a function of 1 over the Kelvin temperature. To add in the equation of the line, you can right-click on your data in the graph and go to Add Trend Line or Format Trend Line, and then make sure that you have display equation on the chart, and if you want, display the r-squared value. Then, if for some reason you don't have enough significant figures, you can click on the equation of the line and go to the options for the graph and change the number and the decimal places if you would like. Once you have prepared your Arrhenius plot, you are then ready to carry out the calculations of the activation barrier and the frequency factor. As you recall, the slope of this line is going to be equal to negative EA over R, R being equal to 8.314. So negative 2,767 is equal to negative EA over R, which is 8.314. So EA is simply equal to negative 2,767 multiplied by negative 8.314, and that gives us 23,000 joules per mole, or 23 kilojoules per mole. Then, to calculate the activation energy, we recall that the y-intercept is equal to the natural log of A. So natural log of A is equal to 25.11 if we take the anti-natural log of both sides, e to the natural log of a is just a, and e to the 25.11 is 8.04 times 10 to the 10. That is then our frequency factor.